Hello. Today we're back at it again with another Leetcoders. Well, it's not on Leetcode, but another coding question. Today it's called search in a sorted infinite array, or like theoretically speaking, infinite. They're just emulating the infinite part, but yeah, sounds cool to say infinite though. Anyways, I don't know what else there is to say about this question. So I guess we'll just, without further ado, let us get into the question. So today, given an infinite sorted array or an array with unknown size, find if a given number key is present in the array. Write a function to return the index of the key if it is present in the array, otherwise return -1. Since it is not possible to define an array with infinite or unknown size, you'll be provided with an interface array reader to read the elements of the array. ArrayReader.getIndex will return the number at index. If the array's size is smaller than the index, it will return integer.maxValue. And then the example one, we have the array, but we can't just run length on it, so we can't tell. And then we want to find the output. And actually, let me grab another one. Seems like it's the same thing, but just with a different key that just doesn't exist. And so we want to return -1, right? So without further ado, let us get into the question. Actually, wait, let me put out the expected answers for each one first. So with this array, to find 16, it's right here. That is 4, 7. So that's actually index 6 because 0-based indexing. 11 is the example up here. So it's actually -1. For this, 15 would be index 4. And this one, 200, is out of the bounds. So we will not be able to find it. Therefore, -1. But like these are different -1 responses because this -1 it's not in the bound. And for this -1, it's it's not actually in the array, but this one is just it's way out of bounds for this array. So without further ado, let us get into solving the question. So first we want to define our bounds for how we want to search. We're just going to assume there's at least 2 indices, 0 and 1. So it's actually possible that we just automatically not get anything, and then but it's actually possible to exit out early. Well, not really exit out early, but like our code will handle for everything here. So while reader, since we're passed in reader dot get right is less than key, we want to try to find the right bounds, right? So basically, actually, or yeah, that's fine. So if reader.getRight is equal to -1, actually no, we're not gonna do that. So we'll just do this. So basically, if it's less than a key, then we're just going to be like, okay, we can't find our we haven't found our number yet. So we'll do this. We're going to do new left. Oh, whoops, there's a double register there. We're going to do new left is equal to right plus 1, because in our current bound we already can't find the number, right? So we need to move to the next bound. And so we don't need to check right anymore because right is already not within the bounds of what we want to search. And so we want to do right plus equals. This part is like a little bit of like mental gymnastics in order to calculate it. So let me write this out, and then we could calculate how it works together. And then, so after we calculate our new right bound, we're gonna set left is equal to new left. And then so now we'll calculate how this actually moves our bounds properly. So let us go down here. We're going to comment. We're going to start with 0 and 1. Actually, let me put an extra space because eventually we're going to deal with double digits pretty quickly here. So we start with 0 and 1, right? And now let's just say let's just assume that we want to keep looking. It doesn't even matter what number we're getting right now. We just want to keep looking until the end of the array. So start with 0 and 1. And then so we would now go to 2, right? Because new left, which is what we're going to be using later, is right plus 1. And right is currently 1, so plus 1 would be 2. And so right is plus equals. Remember, it's not right equals, it's right plus equals. So we're adding whatever this number that is calculated on, like calculated to, onto our right. So right is currently 1. Right minus left is 1 minus 0. Plus 1, 2 times 2, 4. So we want so we eventually double our range from 0 to 1, which covers 2 numbers, to 2 to 5, which covers 2, 3, 4, 5, 4 numbers, right? And just to prove that this logic still stands, the new left is right plus 1, which is 5 plus 1, 6. Move this over 2 times. And now we do 5 minus 2, which is 3, plus 1, 4, times 2, 8, and right plus that. So it's actually 13, right? So now our range for here is actually 8 now, because 13 minus 6 is 7, but then you need it, but then if you do that type of subtraction, it only counts everything. It doesn't count one of the edge pieces because you want to count actually how many numbers there are, right? So this is actually covers 8 numbers. This covers 4 numbers. This covers 2 numbers, right? So that effectively will keep expanding our range, and then we also won't recheck anything in the very beginning that we don't need. So that's just to prove this logic will eventually get us to the whoa, I did not mean to move it up like that. This is just to prove that eventually this logic will get us to where we want to be. And then so if we eventually do find our number, or in this case we just eventually keep expanding till our very last window, so 0 and 1, and then we'll go 2 to 5 and 6, 7, 8, 9, 10, 11, 12, 13. So then let's just assume that we keep going to our last window, and then this is all we can get. So we will just not break, but then we'll just run our regular binary search here with the reader key left and right. Yeah, because basically if we go beyond, right, so we calculated what, 6 and 13. So then our next number would be 14 and 6, 13, 7, 8, 16, 29, right? And so we'll run this again, and then we'll get integer max value, which is obviously not less than key, so it'll eventually break. And then we'll just search in that technically imaginary bound, right? So then we'll just end up returning -1 in our binary search anyways. And so now we just need to write our binary search. This is the same binary search that we've always used. So reader key left and right. So since we already have left and right, we don't need to calculate them, right? So mid is equal to, actually no, we want to do while left is less than or equal to right. We'll just do mid is equal to left plus right minus left for division 2. So the reason why we do this is because if you do left plus right floor division 2 that could potentially overflow. And if your right was going to overflow anyways, you would overflow earlier. So if you do right minus left and you floor division that, and then you make your way from left this many spaces over to the midpoint, you shouldn't overflow. And now this is the I'm going to do mid value because I don't want to keep doing reader.get mid. So we're going to do that. We're going to do if mid value is equal to key, then we're going to return mid. And else if mid value is less than key, then we want to do left is equal to mid plus 1 because we want to move our window to the right, right? And else this just holds the value for mid value is greater than key. We want to do right is equal to mid minus 1. And if we never return in our while loop, we want to return -1 out here. And search an infinite array is already called here. So if we call this code, theoretically, we should get 6, -1, 4, and -1. And that is exactly what we do get. Yeah, so with that being said, we are done with the question. Thank you for watching.